Hello students, so today we will start with the second part of magnetic effect of current, and in this second part we will discuss about the magnetic field around current carrying conductor, state conductor is there. So if we see this diagram, in this diagram what is there? We have a wire, and through this wire the constant current is passing through that one, and that constant current is provided with the help of this rheostat. This is an ammeter. You already studied in first chapter that a meter is an instrument which is used to measure the current, and a meter is always connected in series because that resistance is a low resistance device. So that is why a meter is always connected in series. This is the key. This is only to close the circuit. So what will happen when the current passes through the state conductor, and we are putting the compass needle near the state conductor. So when the constant current passes through the state conductor, in that case, that magnetic needle, compass needle, get deflected. So why deflection is there in the compass needle? It is only because of the reason that something is there around that state conductor. So what is that? That is only the magnetic field. Because when we experience something around that state conductor, it is only possible mean if current is there, so what is there in this surrounding? It is the magnetic field. Because of that magnetic field, that compass needle will show the deflection. So, and we will also discuss on what factor the magnetic field will depends. So, if we discuss, then in that case, current is flowing through the state conductor, or current is flowing through the conductor. So, when the current flowing through the conductor, and if the magnitude means strength of the current, you know that 1 ampere, 2 ampere, 3 ampere, 4 ampere and 5 ampere. As we going to increase the magnitude of the current, what will happen? Magnetic strength will also goes on increase. Mean if 1 ampere करंट पास करेंगे कंडक्टर से, तो उस हिसाब से मैग्नेटिक फील्ड प्रोड्यूस होगा. अगर हम 2, 3, 4 और 4 up to 5 ampere we are going to increase the strength of the current. According to that, magnetic field will also increase. So that is why we can say that the magnetic field is directly proportional to the current. Secondly, magnetic field, suppose we place the compass needle at this point, then we place the compass needle at this point, then we place the compass needle at this point. What is going to happen? We are going far away from the current carrying conductor. So if we are going far away from the current carrying conductor, in that case the magnetic field strength will decrease. So you know that we have to obey the every forces obey the inverse scale law. So magnetic field is also going to obey the inverse scale law. So that is why V is inversely proportional to R square. Why it is in the denominator? Because as the distance increases, strength of magnetic field will decrease. So that is why there is a inverse relation between the distance and the magnetic field. Again, I want to explain that as we move away from the state conductor, so in that case, strength of the magnetic field will goes on decreasing. Let me cite this with the help of one example. Suppose we have a magnet and we have a iron piece. If iron piece is very close to the that bar magnet, too much attraction is there, and if it is far away from the that state conductor, in that case magnetic field strength will decrease. So same thing is happening in this case. So that is why magnetic field is inversely proportional to R square. And I also want to discuss that it also depends on the number of turns in the coils. So what type of coils I want to say that if we increase the number of turns in the coil, because if number of turns increases, current will also increase, because in each turn current will magnitude of the current is going to be increased. If magnitude increases, current is simply additive in nature. If we are adding the current, it means that adding the current means adding the magnetic field. Why? Because adding the current means both are again proportional. I have to put N here. If I put N here, it means that magnetic field strength will also increase. So that is why we can say that as the current increases, magnetic field will also increase, and if number of turns will increase, then the magnetic field strength will also increase. So this is the first topic related to the magnetic field, that how we can experience the magnetic field when a current passing through the current carrying state connector. Secondly, how we can explain the magnetic field. We have to explain, that is, we are dealing with such type of quantity which is invisible. Current is also invisible, magnetic field is also invisible, but we can experience that with the help of some instruments, that if we touch the current carrying conductor, then we can feel that current is flowing. But don't go for that, because definitely we got a shock in that case. So do not go for that. But I want to share ki if current is there, definitely magnetic field will be there around that current carrying state conductor. So if current is there around current carrying state conductor, so that is we have to explain, हमें वो explain करना पड़ेगा कि magnetic field होता कैसे है. So in order to explain that things, we have the right. So this is our right hand. We have to explain the right hand thumb rule. This is the thumb. So this thumb gives the direction of the current, and this curly, just curly, do not make it as just like this, but make it as curly in this way, curly. So this curly of finger, curly मतलब थोड़ा अपनी फिंगर्स को सिर्फ घुमाना है आपने, इनको बिल्कुल बंद नहीं कर देना है, मुट्ठी नहीं बना लेनी है, इनको थोड़ा सा ऐसे कर्ल कर लो, घुमा लो. So this is the direction of current. If this is the direction of current, and this is the direction of the magnetic field. So if this is the direction, so see whether it is a clockwise or anti-clockwise. Sorry. So when, now see, it is anti-clockwise direction. This is anti-clockwise. Okay. So when the current flowing in this direction, so magnetic field will be there in anti-clockwise. And if the current is flowing in this direction, so now curl your finger in this way, just if you want to understand this concept by yourself, so just like go by yourself as I am doing, जैसे मैं कर रहा हूँ, same thing you should do when you will see this video. So you have to move curly of finger. This is the curly of finger, and this is the direction of the current. So direction of the current is into the plane of the paper. So if into the plane of the paper, so that is in this way. So that is called clockwise. So one is the anti-clockwise and second is the clockwise. So if the current is moving in upward direction, so in that case anti-clockwise will be there, and if it is in downward direction, then clockwise magnetic field will be there. So I also share with you that what is the meaning of anti-clockwise and clockwise. Listen one thing, anti-clockwise, because if current is flowing, magnetic field is there. If magnetic field is there, magnetic field mean magnetic strength, and for the magnetic strength, two poles are definitely will be there. So one pole is the north pole and other will be the south pole. But I want to say, if magnetic field is produced, it means that pole will be there definitely. So that is why I am discussing ki one is the anti-clockwise and other is the clockwise. So I will discuss later after 1 minute, that is what is the meaning of anti-clockwise and clockwise. So this is known as right hand thumb rule. We can also explain this with the help of screw rule. So suppose this is the screw and this is the length of that part on which this screw will be we are going to be rotate. If we are rotating in this way, okay, so that is, this is the direction of the current, this is the direction, and this is the where, see the things, that is magnetic field will be there around. I am rotating in this way. If the current is in, so that is rotation are coming in just like that. If the current is coming outside, so just we are opening this screw. So if we are opening, so it means that it is coming outside. So screw is coming outside, and in the first case screw is going inside. If it is going inside, it means that one direction is there. If it is going outside in the test, another direction will be there. That is, one is anti-clockwise and same things, the other will be in a clockwise direction. So this is how we can explain the direction of the magnetic fields when the current flowing through the state connector. Next topic is magnetic field in the circular loop. So circular loop, for the circular loop we have a one, this is the ring. Let me show you this ring, because in order to explain the circular loop we require this loop. So this is the loop. I am putting this loop in this way. So if we see that this is the loop, so current is flowing in the down part. So this is the down part. This is coming in this way and this in this way. So if current is coming in this way, that is this way. This is the way. So current is moving in this, and this is the our curly of finger. So curly of finger is now in anti-clockwise, and in the upper part current is coming, so that is in clockwise. So there are two parts. Lower part appear to us that is it is anti-clockwise, and upper part appear to us that it is in clockwise. So again I am saying that if current is flowing through the circle loop, from where the circle loop will come, we have a state conductor. Convert that state conductor in the form of loop. If I move for a state, it will become state. Then go for it to rotate, then it becomes circle loop. It means that a state conductor, if when in this form, then it will become a loop. So if it is a loop, it means that again current is flowing. So if current is flowing, again magnetic field will be there around that state conductor. So if it is in the down part, according to this, if the current is coming in the down part, so that is near down part will become anti-clockwise and upper part will become clockwise. And if the now see the things, what will happen? This is anti-clockwise and this is clockwise. So if we see the fingers, you have to, because one more person is required, otherwise how it is possible, because I have only one right hand, so it is not possible to explain with the one right hand if I have second right hand with me. So in that case what will happen? Current is coming in this way, so that is the loop, that is the direction in this way. Okay, so what will happen if we see the central part? In the central part, one is in anti-clockwise and other is in clockwise. It means that two poles will be there. Again anti-clockwise mean north pole is there, and clockwise mean south pole will be there. So remember this thing, that if the current is flowing and magnetic direction of the magnetic field is in anti-clockwise direction, then that part is a north pole, and where the current appear to us, that is in clockwise direction, then that part is behave as a south pole. Why I am saying that thing? Because if magnetic field is there, the magnetic field is there, pole definitely will be there. So if pole are there, so north and south pole will be there. So because सिंगल पोल डज नॉट, पोल मीन नॉर्थ पोल और साउथ पोल को हम अकेला नहीं कर सकते, अगर उसको काटेंगे तब भी हम हमारे दो पीस बनेंगे। कल आपने देखा था, फिर से नॉर्थ साउथ बन जाएंगे, फिर से काटेंगे, फिर से नॉर्थ पोल, साउथ पोल विल बी देयर। So if it is not possible to separate, then how I can separate? In the case of current carrying stator, it is not possible also in that case. So that is why I want to share that if a current is flowing, whether it is state conductor or it is circle loop, formation of north pole and south pole definitely will be there. So that is the meaning of this circle loop, and that is anti-clockwise mean north pole is there and clockwise mean south pole will be there. I also want to share one thing more with you about this right hand thumb rule and also about the magnetic field. If you study it, we have three axes. You are a student of 10th standard. If you not studied, only plane is studying. So let me share with you these are the three fingers. So three fingers mean 1, 2nd and 3rd. All these three fingers are perpendicular to each other. Stretch so that they appear to us as mutually perpendicular. So what I want to say, now see here, if this is the direction, it means that magnetic field is coming in these two planes. What I want to say, it means that if current is flowing in this direction, so magnetic field कहाँ होगा? X में है तो by z plane में magnetic field is there. और if बाकी we will discuss in higher classes, फिलहाल आप यही रखो कि वो plane में होता है, और plane का मतलब क्या होता है? X y, y z, z x. That is, if current is flowing here along x axis, then y z plane, y axis, then z x plane, z axis, then xy plane is there. So that is the meaning of plane. plane you are already studied, but that is only xy. But I am sharing with you three dimensions, that is x axis, y and z axis. It means what I want to say कि हमारा अगर current ऐसे है, so then magnetic field will be produced in the other two planes. So this is about the magnetic field, and this is about the right hand thumb rule, and this is about the magnetic field in the circle rule. And also I want to discuss with the solenoid with you, but I will share that solenoid in the next lecture when we go for the part 3. Till then, goodbye.